Hi everybody, and welcome to part 2 of our crash course on mixed model material management. Now part 2 will talk about the specific tools or methods that you're going to want to apply to accomplish that. And again, crash course means we're going pretty fast. But here's the good news. Right at the bottom of this page, of this window, there's a button and you can download the material management roadmap. So there's a lot of detail that we're not going to be able to cover in this short lesson, but you'll be able to go back and find out more and really understand the entire process from start to finish of designing a material delivery system that can accomplish these requirements. Just to recap, these requirements of dependability, that is not running out of parts, low inventories, efficient. Okay, so let's go through the main tools. The most important one, maybe, or at least the first one we're talking about, is called Plan for Every Part. So the idea here is that for every item that's manufactured and purchased, for every item, you have a easy-to-access record of all of the data elements you might want to know about that part. So picture just could be a massive Excel spreadsheet, and the columns are the data elements, and the row is the part number. Now, it doesn't have to be an Excel spreadsheet. That is very common that you'd use that tool, but the main point is that you can see everything on one screen, or at least you can scroll right and left, and you can see everything in one place. And the advantage of a tool like Excel is you can sort it, filter it, slice it, dice it very easily. Things that you can't do that easily in an MRP or ERP system. Now, we must say that most ERP systems have a lot of these data elements in it already. You might say to yourself, well, we have an item master, we have demand information, we have supplier information, etc. But the problem is it's not in one place. It's scattered in different modules, and it's really hard to get the total picture for any given item. Now, could you have a view in an ERP system that does give you that? Sure, why not? But most systems don't have it. So the other thing I'll mention is that there are data elements that may not be in your ERP or MRP system. For example, calculating Kanban quantities the way you'd like to do it. Is that a function, a part of your ERP system? Maybe yes, maybe no. So there's definitely advantage to having a flexible and user-friendly kind of environment. So you want to have a plan for every part. Recommendation when you're creating this is don't try to bite off too much in one effort. In other words, don't try to just simply import all of your part numbers into one massive spreadsheet and then hope to make sense of this. It's better to take a subset like a commodity code, like all of your fasteners or something on that level, and try to do a complete horizontal job across all of those columns that you're going to want to have. And then you take the next commodity code and proceed in that way. All right, so you need a plan for every part, and you're going to be building on this as we go through here, step by step. Next one, you need to calculate quantities, inventory quantities, that you're going to want to have for every one of these items. Not just at the point of use or point of uses, because you could have more than one for the same item, but also a Kanban supermarket that we'll talk about in a minute. So you need to apply the Kanban quantity or calculation formula on everything. Go ahead, the calculations are free. Calculate it for everything, even though everything may not end up in a Kanban system. But the main thing is you want to have fixed quantities and manage a pull methodology based on those fixed quantities. There's no other way to control inventory unless you start doing that. If you allow inventory or parts to be pushed onto the floor, very difficult to control the quantity that's on the floor or control your inventory turnover. So calculate quantities. These are columns in your Plan for Every Part database, but you'll have to have some idea of how many. And to do that, you have to have some idea of usage. So you may be going back to your ERP system to know, what's my usage on these various items? Okay, third step. Once you have those quantities, you're going to need to design a pull system. By that we mean some of these items on your list are going to be very low usage. I don't use them very often. An option, for example. And those would not be good candidates to include in a Kanban system because for long periods of time they're not going to be consumed. Other parts, because of their size, because of their weight, are not going to be good candidates for a Kanban system because pretty much you have to special handle them in some way or another. Or they're very bulky or they occupy a lot of space. So you're going to know this when you create your plan for every part and actually calculate the quantities. And what you need to do in this third step is really rationalize all of the items and determine which ones are going to be part of a regular Kanban type system and which ones are going to be delivered sequentially, like one at a time or in small quantities, like on a cart, for example, specially designed cart, and which ones are going to be really just planned for individually, maybe even pushed in a sense from your ERP or MRP system because they're very low usage and you just need them when you need them, but the rest of the time you don't need them. Okay, so that's step number 3. Step number 4, containerization. This is really important. What you want to do is establish standard container sizes for use throughout the factory. This could be throughout the company, but usually it's on a plant-by-plant basis. But throughout that plant, you've standardized on certain container sizes. Really hard to plan for storage space unless you standardize on the containers. Now, it's going to be more than one size, but it's going to be a handful of containers that you're going to try to get everything to fit into. Now, there are always going to be the dogs and cats. That's the exceptions that you'll have to deal with on a case-by-case basis. But our goal here is to establish containerization that can handle 90 or 95% of your items. And then you'll have to deal with special carts or other kinds of ways of handling material. So you always have that level, but containerization is really important. And not just within the factory. Ideally, your containerization strategy goes all the way back to suppliers. So suppliers could be delivering material in the same containers that you're using at the point of use. So you don't have to move parts, right? You don't have to repackage parts from one container to another. That would be ideal. So that's the containerization strategy, critically important and sometimes ignored. Next one, you need to design delivery routes. So engineer delivery routes, if you prefer the term. That is, the delivery process of replenishing the points of use needs to be something thought out with standards. So you have standard move time, you have standard picking time, you have standard getting off the tugger, getting on the tugger, picking up empty containers, etc. You have standards for all these things, and then you design a certain number of delivery routes based on a target time. And that target time, to complete the route, that target time should be quite short. And this is the golden key to success. Because if you want low inventories, you're going to have to replenish more often. There's just no other way around it. That's the law of the universe, right? Law of physics. So if you're going to deliver more often, you're going to have to be set up to do that. And that time then needs to correspond to that target, that goal. I'll just give you a case history at Toyota Material Handling in Columbus, Indiana, where they make fork trucks. Their target time for their delivery routes is around 37 minutes. So every 37 minutes, a cart's going to come by and replenish. Now, that they're not replenishing everything on every trip, but every 37 minutes, a tugger will come by every point of use and replenish what needs to be replenished and pick up the empties and pick up Kanban carts as well. They're using paper carts. Okay, so design your delivery routes, however many you need, to accomplish a pretty short cycle time, delivery cycle time, and that's going to really shortage-proof your line and allow you to have low inventories out on the factory floor, which is a big space saver as well. Next one, related again to the plan for every part. So these are all columns that you're populating in your plan for every part. You need to design Kanban supermarkets. If you're going to support rapid cycles of replenishment on the floor, you need to be able to do that easily. And you can't do that easily if you've got a lot of inventory transactions required, or if you have to go back to a warehouse to replenish the stocking carts, etc. So you're really going to need to be thinking in terms of supermarkets. So design of Kanban supermarkets. So you may have a warehouse, you may have a remote warehouse, you may have a warehouse in the four walls of your factory, but the supermarket's different, right? It's a smaller quantity to allow you to easily replenish these carts that are going to be going pretty frequently. So designing Kanban supermarkets is a next step. And then the last one I want to talk about is conveyance. How do you move these parts? Something you'll have to think about. Again, that's another column in your plan for every part database, but how do you plan to move these items? Most of them, I'll have to say, especially smaller items, are going to be delivered via tugger or a cart of some kind. Could be a hand cart. Usually in a larger factory, it's a tugger of some kind, but then you have the exceptions. So you may even have parts that require a fork truck. I mean, that's perfectly possible. You may have parts that require a customized cart to move them. So you may have all kinds of exceptions, but generally speaking, the vast majority of the parts required in most factories, again, I don't want to overgeneralize, but in most factories, it's a tugger system. But you need to decide on that, right? And again, document that in your Plan for Every Part database. So that's just a quick overview for you. Again, this is a crash course, so be prepared for not a whole lot of information. We could talk about any of these subjects for a long time, and we do. So I could go on, but this is the crash course, so I'll pause right here. Refer back to the roadmap that you'll be able to download for a lot more detail on a lot of these items. So if you just look below on this page, you'll be able to click on that button and download, I think it's about a 15-page PDF document with a high-level roadmap and then sub-levels that you can refer to. Now, one more part 3 in this crash course. That'll be the next one coming up. And what I'll be covering in that one are some of the key elements related to running or managing a mixed model material delivery system. Some really interesting things and key points really that can make it or break it in terms of being able to be successful with this kind of material delivery strategy. So with that, I'm going to let you go again, but we'll see you in a couple days for part 3 of the crash course on mixed model material delivery. So I'll see you again.